Hello all, this is Priyadarshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. In the previous video, we were discussing about the limitations of the traditional neural networks, that is ANNs. So the traditional neural networks were very powerful, but it lacks when a sequential data or a time series data is given. So in order to overcome that limitation, we are going to see what is recurrent neural network. So if you could imagine that the first thing we saw, the problem one we saw in the traditional neural networks where we cannot fix the input number of neurons and output neurons while handling the sequential data or the time series data. The second one was the parameter sharing. We cannot give the input sequence in any form we like as how we give in traditional RNN. And the third one was we have to have a humongous computation to compute the sequence of words. So in order to have all these limitations to be overcome, we are going for recurrent neural networks. So in the previous video, we understood what are the limitations of the traditional neural network or the artificial neural network. Now let's define what is recurrent neural network. So recurrent neural networks is also a variant of your artificial neural network, which is taking the input as the time series data or the sequential data. So recurrent neural networks is basically is adapted to work for time series or the sequential data. So in RNN, you have three layers. The input layer in which you will feed the sequence of text, and you have the hidden layers. So this hidden layer is responsible for remembering the specific information about the sequence that is being fed. Remember the Google search that the Google search helps to autocomplete words, is it not? So there it has to have some information in memory and then it has to process. For the same thing to happen, the recurrent neural network has the hidden layers, which is also called the memory layer, which stores the informations and it stores the calculations from the previous time step or the previous word sequence. And then finally you will have a layer called the output layer in which it predicts the output. So a typical RNN looks like this. So the main thing we have to note here is the looping structure of RNN. So here the input is fed as a sequence or time series. It will be fed to the hidden layer. So hidden layer is responsible for remembering the information which is given in the past, and then you will have the output layer, the predicted output. For example, if I give a sentence, the movie is good. So if the movie is good will be processed in different time step. The main important beauty in our recurrent neural network is the movie is good. So it remembers that we are talking about movie. That is, movie has been given in the previous time step that the machine has to remember so that it can give the give the auto-related word, or it can predict the sentiment analysis. So the applications of RNN includes your NLP task or the sentiment analysis, or it can give for product recommendation task also. So the important thing about RNN is the looping structure, as I told you before. So this looping structure is very responsible to have some information in memory, and with that the information what is available in the memory, it processes the input and then finally it gives the output. So when you take the feed forward neural network, your traditional neural network, the input sequence will be fed into the hidden layer or the dense layer network, and then it will process the output. But the important difference is that we are going to give the sequence of data in a looping manner. That is, it will be given, the sequence of data will be given at each time step. So the next time or the current time step, what the RNN does is it takes the input from the present time step, as well as it will go and find the previous time step information also, and then only it process the information. So that is why we are giving it in a looping structure format. So this helps to remember some information and then predict the output. This is the speciality of the RNN. So the previous time step and the present input time step both are taken into consideration for processing the present state output. So this is about RNN. So as I told you before itself, the working architecture of RNN. So this is the general structure of architecture of RNN. So for example, let us consider the movie is good. Okay. So the will be given in this present input. So consider, so this loop is nothing but it has been unfolded many time steps. So same for a particular sequence itself, this will be looped back. That is, the sequence of data will be fed in different time steps. For example, I told you the movie is good. So the first thing at first time step, the input that has been fed into the RNN is the. So it will process the information, and then the output of this information is again fed back into the second time step. So now for movie input, you will have the movie also. With that, it will also have the information that what it has seen in the previous time step, that is the, and then it processes the information and predicts some output at this present time step. Again, this information, the movie information, will be fed back into the next time step, and then it will process the information, and finally you will have all the informations, what at all to remember, will be given into your final step of your RNN. With that, it will process the information. For example, it may be a sentiment analysis. So if we take the movie is good, the final output would be a positive sentiment. So this is how your architecture of RNN or the working style of the RNN. Thank you.